Now moving on to the 16th question, we are asked the correct order of the solubility of alkaline earth metal sulfates. Now the solubility orders of the group 2 compounds like hydroxides, sulfates, carbonates, bicarbonates, nitrates, they are very important for the JEE, so you should also prepare them for the JEE Advanced. And I've taken these two notes from the NCERT salt examples. Okay, because these questions are so important that NCERT has given that these two problems as solved example, and this has been asked in the last year's JEE Advanced also. Okay, so hydroxides show increase in solubility down the group, whereas the bigger anion compounds like sulfates, carbonates, they show decrease in solubility down the group. Okay, so in the metal hydroxides, it is mainly because of the OH negative, that is smaller in size or comparable in size to the cation. But in case of carbonates, sulfates, the anion is much bigger and the lattice energy calculations are mainly dependent on the bigger ion. Okay, so that is the main reason, just to give you a rough idea. Okay, so about hydroxide among alkaline earth metal hydroxide, the anion being the common, the cationic radius will influence the lattice enthalpy. So here, since hydroxides OH negative are not very big anions, hence the cationic radius, cation is responsible for the major change in lattice enthalpy. And as you move down, the lattice enthalpy decreases more than the hydration. Okay, solubility mainly depends. As you move down, the hydration also decreases, lattice also decreases. But which property decreases more will decide the net delta H of solubility or solvation. So here, in case of hydroxides, the lattice enthalpy decreases more than the decrease in hydration enthalpy, and the solubility increases. I hope you're getting my point, because I don't want to go into the detail, otherwise it will take too much of time. And in case of carbonates and sulfates, the anions are much larger. That is why the lattice enthalpy is decided mainly by the anions. And as you move down, sulfate is the common anion, so lattice enthalpy is almost going to be constant. Not exactly constant, almost constant. So hydration is decreasing. Okay, you're getting less and less amount of hydration as you move down, but requirement to break the lattice is same. So in sulfates, as you move down, suppose delta H lattice is 50 and delta H hydration when you started was 60. Now this will decrease very slow, like 48, 47, 44, like that. So this is the energy required to break the crystal, and this is the energy that you have. So on the top you have more energy and less is the requirement, so it will dissolve. So it dissolves. But as you move down, in case of sulfates, the hydration enthalpy decreases, okay, more rapidly than the lattice. So it will be like 60 to 50, then 40, then 30, like that. So now you can see here it is still a little bit more, so it will also dissolve to some extent. Here it will not dissolve, here it will not dissolve. Okay, so it is the difference between the lattice and hydration energy, how these two parameters vary on going down or above a group. Okay, so always refer to the NCERT text, it's very important. So according to that, the solubility trend will be, highest solubility will be for magnesium, then calcium, then strontium, then barium. Next is the test to distinguish primary, secondary and tertiary amines. So let's discuss all one by one. Now, carbylamine reaction, it is for the detection of primary amines. Okay, and the foul smelling isocyanide is formed, and that confirms the test. It is not for 2 degree or 3 degree amines. Okay, for example, RNH2 plus CHCl3 plus 3KOH in presence of heat, it gives you isocyanide. It's a foul smelling compound plus KCl and H2O. Second, benzene sulfonyl chloride. This is the Hinsberg reagent. Okay, so it means we are talking about the Hinsberg test here. It distinguishes 1 degree, 2 degree and 3 degree amines. So this is a very important test to distinguish the 1 degree, 2 degree and 3 degree amines. Third is the Sandmeyer reaction. So these are the two examples of the Sandmeyer reaction. From the diazonium salts, we can directly get aryl halides. Okay, in presence of CuCl, HCl or CuBr, HBr. Then is the mustard oil test. So the action of CS2 plus HgCl2. So it is used only for 1 degree amines, and they form alkyl isothiocyanate, which has a pungent smell like the mustard oil. That is why it is called mustard oil test. But 2 degree and 3 degree amines do not show this test. So the answer is second option, Hinsberg test. If you like the video, please like and subscribe.